Okay, this is the 7th in a series of videos on second order systems, where in this video what we're going to do is we're going to make a model of our system in Modelica and run it and see if we get the same result that appears in the book. The book being, let's see, let me go back to it. So what we're after is we're after this response. We've already gotten a response like this in the open source program that's like MATLAB Octave, and now we're going to do it in Modelica. So Modelica is also an open source program. Let me go to my Word file here because I have a few things to say. Here's our we're working on the Modelica model, a second order underdamped system. We know the values of omega n, zeta, and k. And the second order transfer function is shown here, and that's actually equal to the output, which is the motion over the input, which is a force. Now a force is a step input. So we can actually get the ODE from the transfer function. We simply multiply the denominator times the x, and then we perform the reverse Laplace transform. So an s squared turns into an x double dot, an s turns into an x dot, and then this multiplied by that is just going to be x. And then this k, these are constants here, they get multiplied by the f, and so they're just multiplied by the force. And when we perform the reverse Laplace transform on the force, we simply get the force as a function of t rather than a function of s. So we see we have a second order, that's the s squared times x, 2 zeta omega n times s, and the s turns into an x dot, and then omega n squared multiplied by x converted back into the time domain is just simply x. So the way you deal with this is talked about in chapter 3 of my book, is you solve for the highest order derivative. So I simply algebraically solve this equation and put these other terms over on the right hand side with the force, and I start off with this equation. So this is the pattern that we're going to use when we make our Modelica model. What's important here, as we shall see, is we have three stages of x. We have x double dot, x dot, and x. And so that's where we'll start. Now, I'm not going to talk a lot about how to download Modelica, etc. That's something that you can find already on advice you can find by Googling it, actually. But so you need to download Modelica and then start Modelica. And when you do, you wind up with a screen like this. And what we're going to do, actually what it'll look like, I opened this up already before, it'll look like this. So we're going to create our model, and we're going to use the Modelica libraries to do this. So there's two things we need to do. First, I guess what we should do is start a new file, and we can just call this second order, okay? And it will make a screen up here that's blank, and it looks like a piece of paper with some background here. So what I'm going to do is like blow this up so it's just all white, okay? And there's my model there, as we can see, second order. Now we got to populate it, so what we're going to do is we're going to use there's like a whole bunch of stuff under here that can be used, but what we're going to use is we're going to use these blocks right here. So I open that up, and like I said, we're going to start out with our well, let me explain that. You can look in chapter 3 of the book, and it talks about this in detail for an MCK system. But like I said before, we've got the x double dot, we got the x, and we got the x dot, and then we got the x. So we need you have integration from x double dot to x dot, and then integration again from x dot to x. So we need two integrators, and the integrators in Modelica are found under continuous. So I click here. Oh, there's my integrator right there. So I can just drag this block in here, and I'll put it just kind of in the middle there. Actually, if you can name things, so we can say this is going to be x double dot 2 x dot. Okay? That's the name of our integrator. There it is. Now these turn out to be real big, so I like to reduce them down to size so things fit together or fit on the screen better. Now I'm going to also have another one like this, so I'm going to duplicate this block and I bring it over here. So now I have my what I call my integration backbone. Let's just keep going. You'll see how this works. I'm going to change this to x dot to x. So I go into attributes and I rename it x dot to x. Okay. So out here we're going to have x double dot, which will be converted to x dot, which will be converted to x. Now the way you connect things in Modelica, this is not a tutorial on Modelica, but you go to the output of this block is going to be connected to the input of this block. So I just come over here until the cursor changes. I push the left mouse button, I drag, I let go, and then I bring it over here and click when the cursor changes again. So now these blocks are connected, and you can tell that by moving one of the blocks around. Alright, so I'm going to have x double dot here, x dot here, and x coming out of here. Now, like I said, let me see if I can reduce this in size a little bit. I may just reduce it and then blow it back up again. We need to use this as our guide. So what we're going to do is notice that the x dot is multiplied by 2 times zeta times omega n. And let me go back here again. So I need to get x dot, and I need to bring it out and actually multiply it by that constant. We know what those values are. 2 is 2. Zeta is 0.19 something or other. We can look it back up on Octave. And then omega n is 4 point something or other. I can actually get those. So let me go back to Octave and pull that up. And actually, if we go back, we will see what those are. Yeah, here's our zeta. Here's our omega n. So we might want to keep those. Well, I can always pull them up. I'll just leave this like this. So we want to have 2 times zeta, which is 19620, and then omega n, which is 4929. So actually what I'm going to do is I'm going to put these over on the other screen so I can read them as we're going along so I don't forget them. So I need a gain here, and you get a gain from the math blocks. So there's a gain, just a normal gain. I pull it in here. I'm going to put it down here. And this is going to be, let's see, I'll say 2 zeta omega n, just to remind let's see here. Oh, 2 is, yes, it will not use, I can't use the first a numeral as in the name, so we'll put 2 like that. That reminds me of what it is. It's just for cosmetic purposes, but then I don't have to think about it. And so what I need is, I'm actually going to bring this off and feed it into this block, but I want it to go back the other way. So I can right click here and do a, I thought that was a flip block, but we can rotate it, and then we can rotate it again. And now it's going backwards the other way. So I drag this under here. This is 2 zeta omega n. I pull this off of here. I bring it down, so I've let go of the mouse. And then I actually want to, if I do like this, it's going to kind of make it look goofy. So when I'm out here, I can click on it and it locks it in that position. And I can connect that to that. Okay? Now we need to populate this block. I've just named it 2 zeta omega n, but I haven't put that in there. So if I double click on this, it's asking me what the value in that block is. And we know it's going to be 2 times, and then zeta was 0.1962, I'm reading off of my other screen. And then times omega n, which is 4.929. Okay. So that's what I have now as the value in this block. And I'm going to need to feed it. Let's we've got to look at our equation again. And I tell you what I'm going to do. I've gone 10 minutes, so we're going to need a little bit more time. So I'm going to stop the video and start it back up again from this spot.